that costs me not more than 500 USD or 600 USD. But I have to buy a single laptop of I 15 or 20 processors, 20 CPUs with say 27 or 30 GB RAM. That will not cost me $1,500. That will cost me much more than that. And that's the reason the vertical scaling is not only complex, that is costly also. And that's the reason that systems are said to be economical rather than buying a system which has such a kind of processing power. I buy 3 commodity hardwares which are cheaper for me and put them in my cluster, and that's the reason the system is economical. Efficient, by distributing the data and doing a parallel processing, the system is very efficient. Why the system is reliable? It maintains multiple copies of your data. People from data warehouse background, please try to digest this thing. It tries to maintain multiple copies of your data automatically into the cluster. So when you copy a file into LTFS Word, at least 3 copies of that file would be available in different data nodes across the cluster. Why, how, I'll talk about that things. But this is how the system is made reliable. So when one node is down, the copy of that file is available in some other node, and that is what makes the system reliable. I'll be talking about this in more detail in my next slides. But these are few things what makes Hadoop really useful. Any questions on how the system is scalable, economical, efficient, and reliable? Abhijat says, could you please explain? Okay, Rohit, I know it's redundant. Okay, so before coming to Rohit, Abhijat has asked me a question. Okay, before that, Kamaljit also said. Okay, so Kamaljit and Rohit, you had same questions, 3 copies, and Rohit also says, isn't that redundant? I'll be coming to you in a minute. Avijat says, could you please explain the economical section again? So by economical, Avijat, I'm trying to say to buy systems which are vertically costly. So in this example, what I was saying is you have to buy 3 laptops of i5 kind of thing, 4 or 5 processors with 8 GB RAM, and that cost me around 500 USD each. So in total, that cost me 1500 USD if I have to say buy such 3 laptops. But if you have to buy a single laptop with 20 CPUs kind of thing, approximately 5 into the 15 CPUs kind of thing, and 8 into 3 GB RAM, 8 into 3 GB RAM, bear with my writing, sorry for this pathetic writing. So if I have to buy such a laptop, that won't be possible for me to buy in 1500 USD, that is 500 into 3 USD. That will be much higher than this. So that's the reason the system is called economical. I can buy cheaper hardwares and add that to system, and I can make an economical system rather than expensive vertically scaled servers of IBM or you know the vertically high huge processing power servers. Avijat, does that answer your question? Yes, cost would go, but the rate at which that cost would increase in scaling it horizontally would be much lesser as compared to horizontal scaling. Yes, Abhijat, performance is linked with the aspects of the machine, so that's the reason I'm okay. Just a minute. Give me a sec. And don't want to hold the class. Okay, let me. I want to clear it out. Just give me a sec. I hope everyone can see my Excel sheet. Akash says no. Now can you see the Excel sheet? Okay, everyone says yes. Okay. Okay. So what I'm saying is, say I have a only these 3 for timing. say they have a configuration of say 2 CPUs and 8 GB RAM. If I have to make such system or I have to buy such system, it will cost me approximately say 500 USD. Just I'm assuming this thing. Probably it costs the same. So in total, it will cost me 1500 USD. But I have to buy a system. I have to just rather than three systems. What I want is one node with 6 CPUs and 8 into 3 GB of RAM, that is 24 GB of RAM. That won't cost me 1500 USD definitely. That will be much higher than this. So that is what I'm saying, or emphasizing on that this thing. This is what makes the system economical. We can add cheaper hardwares into the system, and that the cost of these cheaper hardwares, there would be definitely a cost involved. There will be definitely the processing power will definitely depend on the system. But based on what hardware we are adding, that is economical as compared to vertically scale. Now, if next day I have to increase 2 more CPUs in the system, that will be much costlier as compared to buying a new laptop or as compared to buying a new commodity hardware of this configuration. That is what I was trying to say. Okay. Yeah, the keyword is commodity. Yes, perfectly right. So Abhilash says the keyword is commodity with a smiley. Yes, definitely the keyword is commodity. You can buy commodity hardwares, cheaper hardwares, and add that to your cluster. And why I can buy commodity hardwares, I'll further on slide will explain you why commodity hardwares or cheaper machines or machines which are not even reliable, which can fail down very soon, can even help you in higher processing power, achieving higher processing power in the system. Okay, okay, I hope that answers Abhijat. Then Rohit has a question. Where is it gone? Rohit, you asked some question. I think I missed your question. Could you please repeat that? You were asking something related to redundancy. I'm not sure. I'll just unmute. Okay, Rohit has sent that thing to private to me. So Rohit says 3 copies will cause redundancy. Grish, yes, I will be taking 10 minutes break after I complete the slide. I also prefer 10 minutes break because I'm also speaking from long. So we will take a quick 10 minutes break after I just answer this Rohit's question. So Rohit, yes, the data is redundant, but we get a lot of other benefits with this redundancy, and that's the reason I told you prior speaking to that. Please try to digest this concept. The redundancy is not a bad thing in the system. The days are gone when hard disks used to be pretty high. The cost of storing the data was very high. We are looking into the era when Akash, I'll just come to you. We are working in the era where storing of the data is not a costly task, and replicating the data helps in many aspects, including the reliability of the system. If something has gone down, I'll give you an example also after the break, how that helps in more, and furthermore slides will also explain you why the redundancy is not a bad thing. So it would take for you a little time to digest this thing, but yes, the redundancy is not a bad thing. Though the days are gone when people used to say don't make your data redundant, do as much normalization in your data warehouse design as much as possible. Days are gone. People try to keep data as much as unnormalized as they can, rather than using 3N kind of format. People are not even using single N's also these days and the reason behind that is the storing power of the system is pretty high, and the processing power we can use of the system to process the data. Rohit, does that answer your question partly? I hope not fully, but partly. Okay, Rohit says yes. Okay, so guys, let's take a 10 minutes break. It's 8:30 IST in my watch. I'll be back at 8:40 IST, and same you can take care in your watches in your respective time zones. Sure. Okay, everyone says okay. Sure. So I'll also mute my mic and let's meet in 10 minutes. guys, I'm back. Just ping me if you're back. Yeah, Vijat, this is chat for everyone. You can send individual chats also, but this chat is for everyone. Girish also said he is back. So Vijat is back, Girish is back. Yeah, Vijat, you can just tell me your question. Kamalji says I'm back. Okay, what is big data? Sure. So any data which is pretty big for your traditional systems to handle, not only big in terms of volume of the data, but the complexity of the data, the type of data structure and structure, as well as the rate at which data is growing. So the enormous amount of data is said to be big data. So any big data, the term itself is big data. So any data which is very big, not only in terms of size, but also about the complexity. So that data requires high processing power to process, to look into the data, and that data is said to be big data. And we use Hadoop, a framework, to process that data. And could it be data in Oracle DB? Yes, definitely, Akash. That could be a data in is that just a concept? Yeah, that's just a term which says data is big. The data which is big for traditional systems to handle, that the data is called a big data. And there is no predefined size limit that if the data is more than 1 MB, that is said to be big data. If the data is more than 5 petabytes, that is said to be big data. Any data can be big based on your requirement, based on your complexity of the data, based on your processing involved with the data. So any data which is pretty big for traditional systems to handle is said to be I won't say it's which is complex for traditional system, but any data which is pretty big and need to be processed is said to be big data. There's no predefined definition of big data, or not predefined data limit which is said to be big data. Akash, could that be a data in Oracle DB? Definitely, that could be a data in Oracle DB also. Take data present in stock exchange. Yeah, definitely the data which Abhijat says the data which is generated out of a stock exchange, either out of tick or either out of trades or orders. Yeah, definitely that is a big data, because the data which is generated out of stock exchange is pretty high and pretty huge, and that really requires high complexity to process the data. So Vijay said, okay, understood. Is this roughly 1 TB of data per day from? It's roughly 1 TB of data per day from NYSE. Yeah, probably that could be 1 TB of data. I'm not sure about the figures, but definitely that could be 1 TB of data per day out of NYSE. Can RDBMS also be hosted on multiple nodes? Rohit, yeah, but such kind of parallel processing, such kind of framework is not available in traditional RDBMS systems. And I'll be talking about the architecture about this system, and that will give you a more deeper insight why that is. First thing is your data is not reliable in those systems. Those systems are not scalable. So this system, although they are scalable, I won't say they are not scalable. They could be scalable, but they are not economical as Hadoop cluster is, because you can just add the commodity hardware. Those are not so much efficient as the Hadoop system is. Those are definitely not reliable if your database is down. Let me give you an example. Me and some of my friends planned for a party over Friday night. Our data was in one of the data centers. As our data was distributed across data centers and we were maintaining multiple copies of data center, the data center gone down, and the friends with whom I was planning a party was cancelled, because those friends also had the data in the same data center, and they have to spend whole weekend in the office to resolve the data center related issues. But as our data was like in different nodes was available across the cluster, that was transparent to the clients, and they were able to get their data, and that did not affected anyone in the Hadoop world. But as they were storing a single copy in their data center and their data was not distributed across the cluster, they did not have their distributed copies of the data. They have to resolve those issues, getting the data center up and things like that over the whole weekend. And that is make the system reliable. Yeah, definitely RDBMs can do a parallel processing, but they do not have such kind of framework or architecture. What I'll be talking about in next few of my slides. So Rohit, does that answer your question? Okay, Rohit says yes. Okay, any other questions? Okay. So these are the assumptions on which Hadoop works. I'll be coming to this slide. Okay, okay. Whenever I come to the slide, I recall one thing. So guys, actually, many times we face issues. Might be joining the GoToMeeting or with the link. There's issues with the link with some particular person or things like that. And at that time, we don't have any communication medium because we are across geographies, we are across time zones. So I just request every one of you to add me on the Skype so that if you are facing some issues while joining into the meeting and things like that, now we have some communication medium and we can communicate over the Skype what is the issue we are facing, and that helps us to keep in touch. So I'm just pinging the Skype ID on the chat window. Please add me on the Skype so that we can get in touch if we are facing issues with the meeting someday. Oh, sorry. So this is the correct one. Please ignore the previous one. This is the correct one. Please add me to on Skype, and I'll create a group for this batch so that if you are facing any issues while joining in or in between the session also, at least we can ping on the Skype and we are aware of that you are somewhere and facing some issues. So that will help each of us. So you can send me a Skype invite. I've got Akash invite. Thank you, Akash, for sending me the invite. And if you are facing any issues, just come on Skype and I'll be definitely be there on the Skype at the timing of the class so that if you're facing any issues with the meeting or something, we can talk it over there. I also get an invite from Karish. Thanks for that. Okay, so as I was giving example in the previous slide, so these are the assumptions or there's a thought process behind creating this architecture. So these are the assumptions which Hadoop assumes, and based on this, the whole framework is designed. So Hadoop says or assumes that hardware will always fail. You cannot stop hardware from failing. No one can stop hardware from failing. No. So hardware will always fail. Applications need a write once, read many times kind of access. So the data which is generated, either a user generated data, machine generated data, or whatsoever is the kind of data, the enormous amount of data which is generated is written once into the systems. However, that would be read many times to do different analysis, to do different things on the data. And this is the second most assumption on which Hadoop works. Third thing is IO is always a bottleneck.